Annyeonghaseyo, Shun Halo. Hello, good day. I am Mom Jenny, your science teacher. Come and join me for another interesting and exciting topic in science. Let's start. Before we discuss the most essential learning competencies in Science Grade 8, we will have a review of what you have learned in Grade 7 about force and motion. In Grade 7 Science, you described an object's motion in terms of speed, velocity, and acceleration. You performed activities wherein you interpreted or created visual representations of the motion of objects such as state charts and motion graphs. The concepts were arrived at by studying examples of uniform motion or objects moving in straight line at constant speed. Then you were also introduced to non-uniform motion, where the object covers unequal distances or displacements at equal intervals of time. When a jeepney starts moving, it speeds up. When a jeepney nears a stop sign, it slows down. The jeepney is covering different displacements at equal time intervals, and hence, it is not moving at a uniform velocity. In other words, the jeepney is accelerating. Speed is simply how fast, whereas velocity is how fast and in which direction. Average speed is the distance traveled divided by the time interval for the motion. Average velocity, defined as the displacement divided by the time interval during which the displacement occurred. And acceleration is the quantity that describes the rate of change of velocity in a given time interval. Most of the motions we come across in our daily life are non-uniform, and the primary cause of changes in motion is force. In this module, you will learn about the effects of the force on motion. But before that, let us try to answer the following questions. You may write your answer on your notebook. 1. What makes objects move the way they do? 2. Why do objects move in different ways? 3. Why are some objects faster than the others? And 4. What makes objects stay in place? I will give you 10 seconds to answer these questions. 5, 4, 3, 2, and 1. The answer is very good. Force. Before we continue, I would like to reiterate that change in motion is acceleration, and acceleration is caused by a net force. We are constantly repeating the term or the word force. But what is force? Can you use the pictures on the screen for you to give your own definition of the word force? Can you write your answer on your notebook? can see. Our common sense idea of force is that it is a push or a pull. Notice that our careful choice of words, we refer to a force rather than simply force. We want to think of a force as a very specific action so that we can talk about a single force or perhaps about 2 or 3 individual forces that we can clearly distinguish. Hence, the concrete idea of a force acting on an object. There are 2 important concepts in relation or which is related to force. 1, a force is a push. In Filipino, we call it tulak or pull, hatak. Again, a force is a push or pull on an object. Tulak o hatak. Number 2, movements of objects is due to force. Let us have some description of force. Let's describe what force is. So, on the picture on the screen, you have there a kid or a man. So, parang sinapak siya. Implicit in our concept of force is that a force acts on an object. In other words, pushes or pulls are applied to something that is an object. From the object's perspective, it has a force exerted on it. Forces do not exist in isolation from the object that experiences them. So as you can see, the force was exerted by another object or another person, and it is towards another person. Next is, as you can see, there is a boy playing sepak. It has a Filipino version, we call it sipak. Every force has an agent. A force has a specific and identifiable cause. If a force is being exerted on an object, you must be able to identify a specific cause that is the agent of the force. In the case of this picture, the agent of the force is the kick exerted by the boy towards the sepak ball. What do you call this? This one. Next is, are you familiar with the billiard? The game billiard? Force is a vector quantity. When we say vector quantity, it has magnitude and direction. The strength of the force and its direction. If you push an object, you can push either gently or very hard. Pag nagtutulak tayo ng isang bagay, pwede natin itong itulak ng may malakas na puwersa o kaya itulak natin ng marahan or may mahinang puwersa. Similarly, you can push either left or right, up or down. Pwede nating itulak papunta sa kaliwa, pwedeng pakanan, pwedeng papunta sa taas, at pwede ring papunta sa ibaba. To quantify a push, we need to specify both a magnitude and a direction. When we say magnitude, it is the strength or how strong a force is. A force can either be contact or non-contact. We have here 2 pictures. Between these 2 pictures, which do you think illustrates a contact force? And which picture illustrates non-contact force? Very good. The picture which illustrates contact force is this man playing baseball. There is a contact between the baseball bat and the ball. That's why it is considered as contact force. While the second picture, an apple falls from a tree, is considered as a non-contact force. Let us find out why. On the next slide. The pull of a planet on an object on or near the surface is called the gravitational force. So what causes an apple to fall is because of the pull of gravity, hatak. And everything that has mass has gravity. Our planet, which is the Earth, pulls everything above it. And that type of force is gravitational force. The agent for the gravitational force is the entire planet. Gravity acts on all objects, whether moving or at rest. Remember that what goes up will goes down because of gravity. Here is the picture of the legendary apple and this one of the most popular scientists of all time, Sir Isaac Newton. Next is the spring. Springs exert one of the most common contact forces. A spring can either push when you compress it or pull when stretched. Next is when a string or rope or wire pulls on an object, it exerts a contact force that we call the tension force or tensional forces. The tension within a rope and the tension force experienced by an object at the end of the rope are really the net spring force being exerted by billions and billions of microscopic springs. But just a reminder, don't do it to your classmates. Next is the force exerted by a surface, the agent, against an object that is pressing against the surface is called as the normal force. In essence, the normal force is just a spring force, but one exerted by a vast number of microscopic springs acting on an object. So when you place something like a book on top of the table is pressing against the book because of normal force. And lastly, we have friction. Friction, like the normal force, is exerted by a surface. But whereas the normal force is perpendicular to the surface, the friction force is always tangent to the surface. The first example is the children riding on a sled. This sled is used in countries with what do you call that? With snow. They used to ride it on it. Kinetic friction opposes motion. Next is a log and a frog. Static friction acts in the direction that prevents slipping. So, hindi nadudulas yung palaka pag kumakapit sila sa kahoy or kahit madulas pinaka-puno, hindi nalalaglag yung palaka because of static friction. So also, friction is the reason why when we walk, hindi tayo nadudulas. But you have to be careful kapag yung semento ay bagong floor wax or bagong lampaso, bagong punas at basa. Di ba may mababasa tayo na slippery when wet because of lesser friction. Friction can be disadvantageous pag meron tayong mga gate, kinakalawang, nahihirapan tayong buksan. That is because of friction. So, to lessen the effect of friction, para hindi kayo mahirapang buksan yung kinakalawang nyo na gate, or para hindi maingay yung pagbukas-sara ng pinto, pwedeng lagyan ng lubricant such as oil. Pwede nating pahira ng mantika or ng langis. Next is we have balance and unbalanced forces. Balance forces, the net force acting on an object sums up to 0. It does not produce acceleration. There is no change in the motion of the object. A body is at rest, remains at rest. A body which is at rest will remain at rest. A body moving with constant velocity will maintain its constant velocity. So as simple as, if the forces are balanced, yung bagay na hindi gumagalaw, hindi siya gagalaw. At yung bagay na gumagalaw ay magpapatuloy sa paggalaw, pero hindi siya babagal at hindi siya bibilis at hindi siya magbabago ng direksyon when the forces are balanced. Whereas, in unbalanced forces, the net force acting on an object is not equal to 0. The net force that we are talking about is the sum of all forces acting on the object. In balanced forces, the net force is equal to 0, while in unbalanced forces, the net force is not equal to 0. Next, unbalanced forces produces acceleration, meaning the object which is initially moving or is in motion will slow down or will speed up, and it causes a change in motion. Yun na nga yung sinasabi ko kanina, when the forces are unbalanced, the object which is initially in motion may speed up or may slow down, or it may change its direction. Now this time, let us have a summary about the differences between unbalanced and balanced forces. In balanced forces, the direction of the forces is opposite. It is equal in size, and there is no change in motion if it is initially in motion. But if the object is at rest, it will remain at rest. Remember that balanced forces has a pair of forces. It is created by either a push or a pull. For unbalanced forces, the forces are not equal in size, always causes change in motion, and can be opposite or same direction. So this time, let us combine the forces. When we combine or add forces to determine the net or unbalanced force, we will limit our discussion to those forces which act along the same line of action. When we say forces which act along the same line of action, let's say one pair of force, one is one is upward and the other one is downward, therefore that is vertical. One is to the left or to the right, that is horizontal. They act along the same line. The algebraic signs positive and negative are used to indicate the direction of forces. Unlike signs are used for forces acting in opposite directions, like in the case of the book lying on the table. The force of gravity can be written as F subscript G or Fg, and normal force or Fn are assigned with opposite signs. Normal force is given a positive sign, while gravitational force is given a negative sign. If both gravitational force and normal force are given a magnitude value of 3 units or 3 Newton, remember that the unit of force is Newton, written as capital letter N, then the net force along this line, which is vertical, will be net force is equal to normal force plus gravitational force is equal to 3 Newton or 3 units plus negative 3 units or 3 Newton. Again, 3 Newton plus negative 3 Newton is equal to 0. Remember that in your math class, when you add a like sign and the number is equal, you will have an answer which is 0. For us to make it easier for you to understand, in combining forces, if the direction of the forces acting on the object is the same, let's say 5 Newton upward and 10 Newton upward, simply add it. But if the direction is not the same, one is upward, the other one is downward, or one is to the left and the other one is to the right, subtract it. Again, if the direction of the forces are the same, you add the forces. If the direction of the forces is not the same, you subtract the forces and you get the direction of the bigger force or of the larger force. If the sum of the forces equate to 0, they are considered balanced. If the algebraic sum is not equal to 0, the forces are not balanced. So again, if the sum of the forces is equal to 0, they are considered balanced, meaning if the object is at rest, it will remain at rest, or if the object is in motion, it will continue moving at a constant speed or at constant velocity. It will not speed up or it will not slow down. But if the net force or if the sum of all forces acting on an object is not 0, then therefore the object might slow down or is slowing down or is speeding up. This unbalance or net force would cause a change in a body's state of motion. So I think now you are ready for an exercises or a concept check. Number 1. A boy and a girl are pulling a crate at the same time in opposite directions with 20 Newton and 30 Newton of force respectively. So may batang babae at may batang lalaki na naghahatak ng crate ng sabay sa magkaibang direksyon. One with 20 Newton force and the other one with 30 Newton force. You can use this arrow as your guide. One is towards the right, toward the left, and one is to the right. 20 Newton left and 30 Newton right. You have to answer the following questions. Letter A. What will be the net force of the object? Letter B. Will the object move? And letter C. To what direction will it move? I will give you 10 seconds to answer. Remember that if the direction of the forces is the same, you add it. While if the direction of the forces is not the same, you subtract it. 5, 4, 3, 2, 1. Okay, time's up. Let's answer. For letter A, the answer is 10 Newton. Why 10 Newton? That is 30 Newton minus 20 Newton, then you have 10 Newton. Letter B, will the object move? The answer is yes. Why yes? Remember that if the net force is non-zero, it means that the forces are unbalanced. If the forces are unbalanced, it means that the object will have motion. It can either slow down or speed up. Letter C, to what direction will it move? So you just simply copy the direction of the larger force, that is to the right. You can use the word right or simply write an arrow. Number 2. A boy and a girl are pulling a heavy crate at the same time with 15 units of force each. What is the net force acting on the object? 5 seconds. 5, 4, 3, 2, 1. What is your answer? Very good. The answer is 30 Newton to the left, or just draw an arrow to the left. Why 30 Newton? Because we add 15 Newton and 15 Newton. Why did we add? Because the direction of the forces is the same. And finally, number 3. Suppose another girl pulls the heavy crate in with 20 units of force in opposite direction. What will be the net force that will act on the object? You have 5 seconds. 5, 4, 3, 2, 1. What is your answer? Very good. The answer is 10 Newton to the left, or arrow to the left. Why 10 Newton? Remember that when the direction of the forces is the same, you have to add. If the direction of the force is not the same, you have to subtract. So first, we add the forces with the same direction. That is 15 Newton plus 15 Newton, we have 30 Newton to the left. And there is another force acting on the object that is 20 Newton to the right. So 30 Newton, the sum of 15 plus 15, 30 minus 20, then you have 10 Newton to the left. So 10 Newton to the left. Very good. You nailed it. So you level up. You can now proceed to the next lesson for grade 8.
고마워. 안녕. Thank you and goodbye.